Hello, my name is Nick Newell, and today we are going to be talking about creating and securing an AWS network environment as my presentation for CS373 Defense Against the Dark Arts. This is going to be framed in terms of Week 6 content, which was network security. So what is this? This is a setup from zero. That is, I am going to create a network and machines from scratch in the AWS environment and show you how to secure them using Week 6 techniques. Now, there are some things I won't be able to do. For example, I won't be able to show off an intrusion protection system. That's because I'm a poor college student and I can't afford it. So, for example, this is a Barracuda Next Gen Firewall F-Series. It is available on the AWS Marketplace. And as you can see, it costs $1.20 an hour. I don't want to pay that. I am not going to show it off, but it is there if you need to implement it in the network. Now, for other things that I'm not showing off, it might be because it's infeasible, it doesn't exist, or again, because I'm a college student. Also, there's going to be different terminology for some things in AWS. For example, if we look here at the one of the slides from Week 6, this is our defense in depth slide, the firewalls. You can see that it's positioned in 3 places in this network. Once here, between the network and the internet, and then 2, one in front of user workstations, and 1 in front of remote desktop servers and other critical data. Now, these firewalls are broken up into 2 things in AWS: security groups and network access control lists, or NACLs. And I'll be showing those as we go through this presentation. So, really quickly, this is the AWS dashboard. This is where we're going to be doing the majority of our work. This is the VPC dashboard. This is where we handle all of our network infrastructure, so all of the internet gateways, all of the subnets, all of the NACLs. And the other service we're going to be using from the many Amazon provides is EC2, which is all of the network instances, so all of our servers, all of our elastic IP addresses, which are external IP addresses managed by Amazon, as well as things like load balancers, which are appliances that handle web server traffic. So a load balancer would be used if, say, you have a large website that you need to scale based on, or you need to scale to have handle a lot of load. So what you might do is set up 3 clones of the same web server and put them behind a load balancer. And what the load balancer would do is cyclically direct traffic to one of the 3 web servers, meaning that each server is handling approximately 1/3 of the incoming load. This helps handle things like network outages, server failures, or even DDoS attacks, because it can handle the increased load or the increased number of connections that the DDoS would create. So really quickly, what is a VPC? A VPC is the overarching network. So all machines we create are going to be encapsulated within this network. Each has its own route table, gateways, and NACLs. Remember, NACLs are our first firewall analog. And while VPCs can talk to each other, they don't by default. Doing so is called VPC peering. It's defined in a couple different places in Amazon, but it's not going to be discussed in this video. So for the purposes of time, I have created a couple subnets. These are test public A and test private A. Well, wait, why did I create 2 subnets? That's because this is going to be our second stage of encapsulation. Not all machines need their own external IP address. In fact, not all machines need to connect to the internet. Some machines, or some servers that do, are, for example, web servers, or remote desktop servers, or mail servers. Things that don't want external internet traffic connecting directly to them are things like file hosts or SQL servers. So that's where these two subnets come in. The public subnet is going to have two things in its route table. It's going to have a local routing, so anything within the within our demo VPC is going to be handled internally by Amazon's routing tables. Anything else is going to go what's called an internet gateway. What an internet gateway is basically it allows internet traffic to go through Amazon's backend and connect to the internet. What it does not do is provide an external IP address. So it's set up differently in our private subnet. We still have the same local routing, but for internet traffic, for outgoing internet traffic, we're given a NAT gateway. And what a NAT gateway is it's a construct that sits in the public VPC, or the public subnet, that basically proxies internet connections from the private subnet. So the NAT gateway has its own external IP address, and let's say a server in the private VPC or the private subnet wants to connect to Google. It would say, okay, this is an external IP, go through the NAT gateway. The NAT gateway would receive this request, proxy it through its own external IP address, and then forward the traffic back through to the server that made the request. This means that while servers can connect out through it, other servers can't connect in. So anything on the internet cannot connect to a server behind a NAT gateway. This is very important, and it will help us with privacy a little bit. So, we can see here that our NAT gateway is here. It is in our public subnet, and it is given a public IP address. So, some things we need to set up first are network ACLs. Remember, this is our first firewall analog. If our network was a house, this would be our front door. So, what are some things we might want to include in our front door? So let's say that we have a known bad IP. Let's say that this person at 23.37.128.15 was a known hacker. He'd attacked us in the past, and he doesn't want to legitimately use any services we offer. Well, in that case, we block any and all traffic coming from him. Now, what NACLs do is they go by rule number from top down, so low number to high number, and the first match is the rule that gets followed. So in this case, anything from this IP address is denied. Absolutely anything. Otherwise, next rule, let's allow people to ping our servers to see if they're up. Other than that, let's allow people to connect on high ports to our servers. This also allows return connections if we are trying to connect to a external server. Let's say we have some web servers set up. So we need to allow people to connect to us on port 80 and port 443, HTTP and HTTPS. And let's say that we're on an office network, and we need to be able to manage our connections coming into, or we need to manage the servers on our subnets here. Well, all of our public IP addresses are on this particular subrange. So we're going to allow all connections on this subrange to try and RDP and SSH into the network. Well, wait. Doesn't that allow, 255 or so people to try and connect to our network? Yes, it does. But remember, this is only the front door. This is the broadest range of addresses that we might want to allow. So that's for public. What might we want to allow on private? Well, let's say that we have a management server on this particular IP in our public server. Let's say that is our main management server. Anyone working on the back end is going to be connecting through that address. Well, just for the sake of simplicity, for the sake of this test, let's allow all traffic from that address. Okay, that's convenient. It's not necessarily safe, but it's convenient. Note that that is the only address on the subnet /32 that is going to have full access. Anything else is, well, bad. Other than that, let's allow high port in on TCP and UDP. Let's say that we've got a SQL server on let's say we've got a SQL server in the back end, and we want to allow a server on 10.30.10.55. Let's say this is our web server. We have a PostgreSQL server in the back end, and our web server needs to connect to it. So only our web server can connect over that SQL port. And let's explicitly say RDP from our management server as well, and then all other traffic we're going to deny. Remember, this is our private. This is management things that we're allowing now. So this will be, say, remember, this is going to be holding things like SQL servers or file servers. Well, why are we being so strict if only certain things can connect? It's because, well, there are so many old standards that if you leave something open, you might be accidentally vulnerable. For example, TCP 139. It was made very, very famous within the last year by a WannaCry. What it is it's an SMB protocol, which is basically file sharing, but included in Windows servers. And it was enabled by default. And so many people used it, and so many people left it open, and it was vulnerable to attack. So there's so many old standards out there that you want to limit how much can conceivably hurt you. While it's true the robustness principle states that you should be liberal in what you receive and conservative in what you send, there are some things that you should definitely be on guard for, and your front door is not something you want to leave unlocked. So, sure, be open, generally, but also make sure that you don't have a completely open door policy. So, note that you can also... Ooh, that's not good. We can also limit what traffic we send. For the purposes of this demo, I am not going to be showing this off, but it is a possibility because NACLs are both a whitelist and a blacklist. I am following generally whitelist policy here, but as you can see, we do have an example of blacklisting. And let's associate our private test NACL with our private test list, our private test subnet. Alright, well that's all well and good, but that's only the back end. So, let's go to EC2. Remember, these are where our servers are hosted. So we're going to launch an instance. So these are basically image files. These are image files that Amazon provides, although you can get community image files as well. We're going to say, we're going to create our our management server first, because that way we can leave everything else slightly more locked down, slightly more secure. We're going to create just a basic image here in our public subnet, and we're going to say it's on 10.30.10.10. So let's add storage. 30 gigs is fine. We can tag servers. This is very important if you have many instances running, as you can then search or filter by keys or key values. So now we can configure our security group in this step. Now remember, you could just go review and launch here, but you don't want to because of this step specifically. Remember, this is our second firewall analog. If the NACL was our front door, this is our bedroom door. Who do we trust enough to let into our bedrooms? Well, remember, this is going to be our remote desktop gateway. So let's have a basic starting rule set for an RDG server. So things we want to allow are high ports on TCP UDP. Let's say we allow SSH and remote desktop from a very specific IP range. In this case, this is my public IP address. So this means that no one else can try and remote desktop to the server. While you might get a range of people connecting and allowed through the NACL, if they're trying to connect directly to the remote desktop gateway, it needs to be my IP specifically, or it's not allowed. So this is varying levels of granularity. And whereas a NACL is a whitelist or a blacklist, this is whitelist only. Anything that is not specifically allowed is blocked. So let's go ahead and review and launch. So Amazon encrypts the server passwords with a RSA key. In my case, I've generated a key for this presentation. I have it downloaded here. I acknowledge that I have access to this key, or I won't be able to log in. And I click launch. And there we go. This server is now pending. Let's name it, because otherwise we just have nameless instances with instance IDs, which are very non-descriptive. So let's create another server. It's going to be an it's going to be a Windows server. It's going to be a private server this time. And let's say 10.10 or 10.100 or 10.30.100. Let's say this is 10.30.100.50. And this is going to be some private server. So storage is fine, tags are fine, security group, again, I'll create an existing one that I have done already. So let's say that this is a private server. So this is a basic rule set. So this is going to allow any high ports in. It's going to allow remote desktop only from our management server that we have created. And let's say this is actually our web server. Or no, wait, this can't be our web server, can it? Because this is going to be private. So let's say this is in fact a SQL server. So we have a SQL database that that is hosted on this server, and it allows a PostgreSQL connection, which is 5432, from our web server, which is 10.30.10.100. Well, we don't have a 10.30.10.100, but let's pretend we do. Let's pretend we do have a web server that has this internal IP address. Only our web server would be able to connect over PostgreSQL connection to this SQL server. So let's review and launch. Again, encrypt with our test keys. And let's view our instances. So let's name it as test Postgre. Again, giving it a very descriptive name. Now, as it is right now, we will not be able to connect to either server. Why is that? Well, remember, anything in the public subnets need a public IP address. Our test remote desktop gateway does not. So, let's go here. We are given 5 IP addresses by Amazon for free. The only one we have assigned right now actually goes to our NAT gateway. So let's assign this one. We're going to assign it to our test remote desktop gateway on 10.30.10.10. Cool. Request has succeeded. Let's go back to our instances. We can see that it says the instance state is running. The status checks are still initializing. This will give an indicator stating that Amazon can connect to it. And if the server ever goes down or becomes unresponsive, this will reflect that, and it will actually give you a warning, or you can set it up so it will even email you if said servers go down. So let's try and get the Windows password. So to receive the default admin password, we need our key file. So it's in our downloads folder. As you can see, it is an RSA private key. This is very important that you keep this safe, because while you can change this password, this is something that you don't want to go releasing. So let's decrypt the password. We see we have our external IP, our username, and our password. So let's try and connect to it. So as you can see, it accepts the connection. Oops. We do not want to open Outlook. We in fact want to connect. As you can see, we get a certificate error. This is because these servers start out self-signed. Unless you give it your own certificate, this is fine. So go ahead and accept. And as you can see, we are in our management server. Woohoo! Well, let's say we forgot this is in our private subnet or private server, and we want to assign it a public IP. So let's associate an address with our test Postgre. It allows it. Will it allow us to connect, though? So let's go back here. As you can see, our test gateway has its 2 of 2 checks passed. This means Amazon can connect to it no problem. So let's go here. Let's get Windows password. Oop, not quite there yet. But we know that all we know right now is that we have a server with this public IP address. Password's still not ready, so we have a little bit of time. But as you can see over here, this server is now completely operational. We have our public IP address given and our private IP address given, instance type. This is now a fully functional server. We can do with it what we want to. Now we can see here, we're going to try and get the default password for our Postgre server using the same key pair. I'm going to decrypt it. Let's try and connect. As you can see, by this point in time, we had already connected to our Postgre, or we had already connected to our external server, and it will actually give us an error. Now, however, if we try and connect over our remote desktop, let's close out of that. Let's double check the IP. So it is on 10.30.100.50. We can see in our instance, in our server instance, that we are being allowed to try and connect to the server, and it will allow us to successfully connect to our backend. But even though this server has a public IP address, we are unable to connect. Now keep in mind that actual full instances, full networks are going to be significantly larger, significantly more locked down. I've actually implemented this in an internship where we had 3 public subnets and 3 private subnets. The public subnets had remote desktop gateways, they had web servers, and they even had some other non-networked servers that handled authentication. So they were actually handling 2-factor authentication for the remote desktop gateway. Now, the route tables for those were basically the same, but the network access control lists were very, very, very different. They use the same principle of whitelisting. So allow only what we know is good. In fact, we even had some of these rules say don't allow some of these connections because they were known to be malicious. So while this may be small, this is at a small level what you'd expect to see in a larger environment, but expanded out to include many more possibilities, many more instance types, and many more use cases. My name's Nick Newell, and this has been a presentation of setting up an AWS environment and securing. Have a good day.